diamond ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey, forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and just me, and things gonna improve slowly, because you can't reach down top before top player.
There was a time when immortality seemed the way to enchantment and happiness.
Hello brothers and sisters, so we're here again live on television camera. So we have a question here, say integral 6 square root of 1 minus 4 times square dx. So brothers and sisters, this is how you're going to approach this question. It's very easy. So first and foremost, before we start solving this question, I want to show you something which is very, very important, I think. Okay, very, very important. If somebody give you, let's say integral, and here they give you 1 over a square and then minus, it could be anything, let's say g of x. There's a function here, the square of dx. If you see this format, it has to look the same. This, let me say, arc sine, and then you see this fx squared, there's a root here. Arc sine, and then take this function with no square, so you're going to say f of x over, and then take a with no square. And then you plus constant. Why we plus constant? Because there's no limit. For example, somebody give you integral, let's say 7 negative over, and they give you under root, and they give here 64 minus sine, let's say 4 sine square x dx. So this also it is sine inverse or arc sine. You know why? Because let me do this. Yeah, this is fine. Or I can write here cos, just for a second. Let's say cos. Let's put it doesn't matter even if you say sine. Cos square. This also is arc sine. Why? Because look, so I'm gonna have to change. First of all, I see the root. There's a root. This number, it has to go back because it has to be 1 here. And then what happened? This I have to write as a square, and this one I have to convert as a square. So I'm gonna say integral, and then I'll say take -7 out. Here I'm gonna be left with 1, and then I have my. So this 64, it has to be a squared, means 64 means 80 squared minus, this is 4, and cos squared. So I'll say 2 cos x, and then I'll write my bracket dx. You see, it's already in this format. So this, let me say, -7 has nothing to do with anything. So -7 is out. So when I integrate this, it's going to give me arc sine. So I'll say arc sine, and then I'm going to write this half here with no square. Means, you see, f of x, you see, f of x means something with no square. So whatever we have here, so it's going to be 2 cos x over number with no square, 8. And the plus our constant. See? So this, let me say, by 2, 1, by 2, 4. So 1 over 4. So I could say -7 arc sine cos x over 4, and then we plus constant. So that's how we solve, brother and sister. So now let's go back to the question, because that was not part of the question. Let's go back to the question. Go back to the question. Okay, so I'm gonna raise quick. Just a minute. Then go back to the question. Go back to the question. Okay, cool. So I'm gonna do the same approach for this question. Excuse me. So same approach. So I'll say, all right. So these I have to write as far as sine. So I'll say, okay. So now integral, and they'll say sec square x over 1, meaning 1 square minus, I'll write, because so you have to look for integration. Is not hard, but you have to look which format is this type of integral. So you have to remember those formats. So you need to have a table. I'll try to attach a table on the next video. So table of integration. So this is 4, means I'll write 2, and that's a tan square, means it's going to be tan x, and both of them square. If you square 2, you get 4. If you square tan of x, you get tan of x squared. And they say dx. So the problem here, we don't have a 1 on top. You see? So since you don't have a 1 on top and you're not allowed to take this to the back, you only take to the back only if it's constant, like a number, maybe 1 or 5 or 8 or any number we can take to the back. So for this case, you cannot take this one to the back because you integrate x. So what we're going to do here, we're going to do substitution. You know what we're going to do substitution? If I'm going to take whatever I have here, it's going to give me sec squared. So you need to refer to your differentiation and integration table. You see, you can just Google that one on the internet, or you can check on some books. Like, they always have all the differentiation. If you differentiate tan of x, you always get sec square of x. You have to remember that. So if I have, let's say, differentiation of tan, let's say x cubed, let's say 2x cubed, say differentiate. So what we're going to do, first and foremost, differentiate whatever is in here in front. So when you differentiate this, it's going to give you 3 times 2, 6x squared, because these 3 you're going to minus 1. So differentiating the right at the back. So it's going to give me, or you can say differentiate whatever is in here and the right at the back, and then differentiate the whole is a tan of whatever you have. When you differentiate tan, you get sec square of exactly what you have. See, so this is going to give us 6x squared sec square 2x. I'm sorry that I a little diverge from the main question, because some of the people sometimes don't know. You understand what I'm saying? So that means if I differentiate tan of a function, I mean whatever I have here, that means differentiate this right at the back, means it's going to be f dash, and then when you differentiate tan, you get sec square x. That's what I did here. I differentiate whatever is in here, we should differentiate it, and then differentiate the whole, which is give us sec square. So that's what we do. Sec of a function means differentiate this, you write it at the back, and then say sec of it, exactly what you have there. So now let's go back to substitution. I'm going to raise this. Let me raise. So we're going back to our substitution. So now, how do I know this substitution? Because if I'm going to take 2 tan x, and if I differentiate, it's going to give me sec squared. So that's why I say this is tricky substitution. So we're going to let u equal to 2. You take exactly everything which is in the square here. 2 tan x, and when you differentiate on the left, you're going to get du. When you differentiate on the right, it's going to be 2. You see, this is going to be 2. And when you differentiate tan, it's going to give you sec square of x, brother and sister. So then, what happened? You see, this sec square dx, sec square dx equal to du over 2. So let's divide by 2 and let's divide by 2. So this and this cancel. So sec square dx equal to du over 2. Now we go. 1 is 1 minus 2 tan x equal to u. So now let's convert everything into u. So we're going to say integral sec square dx equal to du over 2. So we're going to say this equal to du over 2. We're going to take this out, and then we're going to say du over 2. And then what we left with on top is going to be just 1 over, and then we're going to have a square root still, and then 1 minus 2 tan x is u. So u. But what happened? There's a square here. Okay. Another thing, this 2 is just a constant, so 2 can go out. So this same is say 1 over 2, and then we have an integral, and then we have a 1, and then we say we have a square root, and then we have a 1 minus u square du. And this is arc sine. That's arc sine right there. So now we're going to say, okay, so now we have 1 over 2, and then this is arc sine. Because I'm going to say arc, then I'll say arc, what? Sine. And then, you know, arc sine is in this format. Root, number square minus whatever you have is square. Okay, so now I'm going to say, okay, so now take whatever you have here, u, with no square, and then take a number with no square over. And then plus constant. Why we plus constant? Because we don't have a limit. So the next step, we're done with the question. Everything's finished. Now you need to substitute back the value of u. Why? Because the question was not in form of u. So what is our u? Our u equal to 2 tan x. So this is going to go, and then we're going to put 2 tan x. U equal to 2 tan x. So finally, we finalize the equation. Arc sine. What is a u? 2 tan x. So 2 tan x over 1. So anything over 1 is just that something over 1. So 2 tan x over 1 is just 2 tan x. So I don't have to write over 1. But if I have other number, I should have written there. So over c. So that's our final answer. Thank you for your time. And if you have any question, brother, sister, you can always leave a comment, or if this video was very helpful, please share with other people. Thanks so much for your time. I appreciate it. Peace and love, man. Peace. Right, so another time again, this is let me just show everybody so that everybody can see clearly. This is Twana Wabantu Academy. I'm saying, and the aim or the purpose of solving this problem is everyone should access free, classic, quality education for all. Means, the aim